Imagine that reality is not made of finished things. Imagine that the world around you exists, but not always in a fully settled form. Not because it is fake, not because nothing is real, but because at the deepest level, reality may begin. Not as fact, but as possibility. This is the question. At the heart of quantum physics, does reality exist before measurement? Before a result is forced? Before a property is fixed? Before a path is known? Before the universe gives an answer? For most of human history, this question would have sounded absurd. Of course, reality exists before measurement. The moon is there, whether anyone looks or not. A stone has weight, whether anyone touches it or not. A river flows in darkness, without needing a witness. The world seems complete. Observation seems secondary. To observe something appears to mean only one thing: to discover what was already there. That is how common sense works. And common sense is powerful because it works beautifully at the human scale. We live among solid objects, stable surfaces, clear locations, definite events. Everything appears settled, but quantum physics opened a crack in that picture. When physicists began studying matter, at the smallest scales that they did not find, tiny classical objects, quietly carrying definite properties, through empty space, they found something stranger. Electrons and photons did not always behave like small pieces of matter. Sometimes they behaved like particles, sometimes like waves, and sometimes they behaved as if what they were doing was not fully decided until measurement occurred. That is the shock. Not that reality disappears, but that reality may not be fully definite before interaction forces a result. Quantum theory does not simply say that we are ignorant. It suggests something deeper, that before measurement, a system may not possess one single classical fact waiting to be uncovered. It may exist as a spread of possibilities, a structured field of what could become actual. And when measurement happens, one outcome appears. One fact becomes real for us. This is where the mind resists, because it wants a hidden answer. It wants to say, the particle had a path all along. The property was already there. The world was complete before we asked anything of it. But quantum theory keeps pushing back. Again and again, it challenges the assumption that nature must contain fully formed answers before the right physical question is asked. And suddenly the problem becomes philosophical. What does it mean? For something to exist, must existence mean having definite properties right now, whether observed or not? Or can something be real without yet being definite? In the classical sense, can reality exist as possibility before it exists as fact? That distinction changes everything. Because if reality before measurement is real but not yet fully actual, then the universe is not. A frozen inventory of finished things. It is a process, a transition, a movement from possibility to event, from potential to fact, from what may happen to what has happened. And this does not only challenge physics, it challenges intuition itself. It challenges the old belief that the world is simply there, complete and settled, independent of every interaction. Because maybe the world is there, but maybe it is there in a deeper, less finished way than classical thought ever imagined. Maybe reality does exist before measurement, but not as a world made entirely of final answers. Maybe before measurement, there is structure, law, potential, probability, relation, but not yet the single fixed fact we later observe. If so, then measurement is not trivial. It is not passive. It is not merely a glance. It is the point where one possibility becomes an event, where the unresolved becomes resolved, where the world does not vanish into view, but sharpens into fact. That is why this question matters, because if measurement plays such a role, then we cannot understand reality until we understand what measurement really is, not as a human act, not as looking, but as something physical, something that turns possibility into outcome. And once that idea enters the mind, the old certainty begins to fail. The question no longer sounds ridiculous. It becomes unavoidable. Does reality exist before measurement? Maybe yes, but perhaps not, in the way we once believed. Perhaps before measurement, reality is not absent. It is unfinished. And to go further, we need to ask the next and more dangerous question: what exactly is a measurement? The word sounds harmless, measurement. It feels technical, neutral, almost boring, as if it simply means to check, to read, to observe. But in quantum physics, measurement is not so innocent. It does not merely describe our access to reality. It may describe the moment reality takes a definite form. That is why the problem begins here. Because if measurement were only a passive act of looking, then the mystery would be trivial. A hidden world would remain the same, and we would simply uncover it. But quantum theory refuses that easy picture. It tells us that measurement is not just knowledge gained, it is interaction, physical interaction. A system does not become measured because a human being stares at it. It becomes measured when it enters into a relation. That produces a definite outcome, a trace, a record, a distinction, something that can no longer remain pure possibility. This matters more than it first appears, because in everyday life, measurement feels passive. You look at a cup, and the cup stays a cup. You weigh a stone, and the stone does not lose its right to have had a weight before the scale confirmed it. Common sense assumes that properties already exist, and measurement merely reports them. Quantum theory does not always allow that assumption. At the quantum scale, to measure is to couple, to connect a tiny system with a larger apparatus in such a way that one outcome becomes actual. A detector clicks, a screen lights up, a value is recorded, and after that moment, something has changed. Not just in us, in the physical situation itself. Before measurement, the system may be described as containing multiple possibilities. After measurement, one result stands out as fact. This is the strange threshold. Before the event, quantum theory gives us a spread of possible outcomes. After the event, we do not experience a spread. We experience one position, one spin, one detection, one mark on the screen, and the question becomes unavoidable. What exactly happened? Between possibility and result, what is a measurement, if it can do that? Some might say it is just disturbance, that the measuring device bumps into the system and changes it. And that is partly true. Measurement is physical, it is not detached. But disturbance alone does not solve the puzzle, because the mystery is not merely that the system is altered. The mystery is that one definite outcome emerges from many possibilities. A quantum state evolves smoothly, mathematically, as a range of what may occur. Then measurement happens, and the smooth range seems to give way to one concrete answer. This is why the word measurement carries so much weight. It sits at the border between two descriptions of reality. On one side, possibility, superposition, distribution, potential. On the other, fact, record, event, outcome. Measurement appears to be the crossing point. But what kind of crossing is it? Is it a real physical transition, a genuine change in the system, or is it only a change in the information available to us? That divide will become one of the deepest battles in quantum theory, because everything depends on how we answer it. If measurement creates definiteness, then reality may not be complete before interaction. If measurement only reveals what was already there, then the world remains classical underneath, and quantum theory is incomplete. This is the fork in the road, and physics has never fully agreed which road is true. Still, one thing is clear: measurement in quantum mechanics does not mean what ordinary language suggests. It is not looking. It is not human attention. It is not consciousness casting magic onto matter. It is a physical process through which distinctions become stable. A system interacts, an apparatus amplifies, an outcome leaves a trace. A possibility becomes irreversible enough to count as an event. That word matters too, irreversible, because measurement is not just an invisible microscopic contact. It becomes measurement When the interaction grows outward, spreading into the world, into a device, into the environment, into a record, into something that can no longer be treated, as if nothing happened. A fact in this sense is not merely a value, it is a value that has entered the fabric of the world. And once a result is recorded, the world itself is different. Not symbolically, physically, there is now a mark, a state, a consequence, something distinguishable has occurred. This is why measurement feels larger than measurement. It looks less like inspection and more like selection, less like watching and more like the birth of an answer. But if that is true, then we are forced to ask, what existed before that answer emerged? Was there already one hidden reality waiting behind the curtain? Or was the curtain itself the wrong metaphor? Perhaps before measurement, there is no single hidden scene. Perhaps there is only a structured set of possibilities, real but not yet exclusive. A reality not absent, but not yet narrowed. Not empty, but not yet decided. And if that sounds unsettling, it should, because once measurement becomes the turning point between possibility and fact, the old picture of the world begins to fail. Reality no longer looks like a finished stage, waiting to be photographed. It begins to look like something more dynamic, something that does not always carry one final answer until the right interaction occurs. And nowhere does this become clearer or stranger than in the experiment. That tore open the heart of classical intuition, the experiment of two slits. If there is one experiment that shattered classical intuition, it is this one. Simple in design, devastating in meaning. A source emits particles, electrons or photons, toward a barrier with two narrow openings, two slits. Behind that barrier is a screen. If reality were classical, the expectation would be obvious. Each particle would pass through one slit or the other, left or right. Two possible paths. And if enough particles were sent through, the screen should show two bands of impact, one behind each slit. That is what common sense predicts. That is what ordinary objects would do. And at first, the setup seems too simple to challenge anything at all. But quantum physics does not leave it simple. When both slits are open and no measurement is made, to determine which path was taken, the screen does not show two simple bands, it shows an interference pattern. A series of bright and dark regions like waves overlapping in water. That pattern means something extraordinary. It means the system behaves, not as if each particle quietly chose one slit, but as if both paths somehow mattered at once. Not just one route, a superposition of routes. Not a hidden decision, but an unresolved structure, capable of interfering with itself. That alone is strange enough, but the experiment cuts deeper, because the moment we try to find out which slit the particle passed through, the interference pattern disappears. Not weakens, disappears. And in its place, we get what classical intuition wanted. From the beginning, two bands, two paths, two outcomes that no longer interfere. This is the wound, because something changes when the path becomes known, or more precisely, when a measurement occurs. That makes path information available. The system behaves differently depending on whether the question is physically asked. And that is almost unbearable for the classical mind, because the mind wants to say, the particle had a path all along. It must have. It went left or it went right. Perhaps we simply did not know which, but the interference pattern refuses that comfort. It suggests that before measurement, the particle is not merely hiding a definite classical answer. Its behavior carries the signature of multiple possibilities, remaining active together. This is why the two-slit experiment is not just a clever demonstration, it is a direct assault on the idea that microscopic reality always consists of fully determined facts waiting to be revealed. And the strangeness grows deeper when particles are sent one at a time, not as a stream, one by one. Surely then, we might imagine each particle would simply choose a slit like a tiny bullet. But no, even when fired individually, the impacts accumulate. into the same interference pattern, as if each particle carries within its motion a spread of possibilities, and the final image on the screen records their hidden structure. This is the part that changes everything. The interference pattern does not come from particles bumping into one another, it appears, even when each particle travels alone, as if the particle does not move, like a miniature stone, but like a quantum possibility, extended across alternatives. And then comes the decisive blow. If a detector is placed at the slits, to determine the path, the pattern changes. The interference vanishes. The result becomes classical, as though the universe itself refuses to produce both a definite path and an interference pattern. At the same time, you may have one or the other, but not both in the same form. This forces a terrible question. What was the particle before measurement? Was it truly in one path, with the theory merely incomplete? Was it in both in some deeper sense that ordinary language cannot hold? Or is the very demand for a path before measurement already a mistake? That is why the two-slit experiment matters so much. It does not merely show that quantum particles are weird, it shows that the old categories, object, path, location, fact, do not fit easily. Before measurement occurs, the system behaves as though reality before measurement is organized differently from reality after measurement. Before measurement, possibility remains spread out. After measurement, one result stands. Before an interference, after selection, before a structure of what may happen, after a definite event, and suddenly measurement is no longer a neutral glance. It becomes a dividing line, a threshold between quantum possibility and classical fact. This is why the experiment feels almost supernatural to anyone seeing it for the first time, not because it invokes magic, but because it reveals that reality at small scales does not follow the grammar. Our senses evolve to trust the particle does not simply behave like a hidden little object, carrying all its answers inside itself. It behaves like something more subtle, something shaped by alternatives, something not fully narrowed until the right interaction occurs. And from here, the deeper question emerges. If the particle is not a tiny object with one definite hidden path, then what exactly is it? Before measurement, what kind of reality can interfere with itself? What exists before one possibility becomes fact? To answer that, we have to leave behind the language of classical objects and enter a harder idea. The idea that before fact, there is not nothing but possibility. After the two-slit experiment, the classical mind reaches for its last defense. Maybe the particle still had a definite path. Maybe the answer existed all along. Maybe we simply lacked the tools to uncover it. This is the instinct. Quantum theory resists because the experiment does not behave as though a hidden classical fact is merely being concealed. It behaves as though before measurement, the system is described in a different way, not as one finished outcome, but as a range of possible outcomes. This is where the word superposition enters, and it is often misunderstood. Superposition does not mean that reality is nonsense. It does not mean that a particle is magically two things. In the childish sense, people often imagine, it means something more precise. It means the state of a system can contain multiple possible results at once before measurement selects one. Not because physics is confused, but because nature at that stage may not yet be committed to a single classical answer. This is the crucial shift. A classical object is assumed to have one actual state. Whether measured or not, a quantum system is described before measurement by a structure. That includes alternatives, alternatives with weights, alternatives with relations, alternatives that can combine, reinforce, or cancel one another. That is why interference appears, because the possibilities are not isolated guesses. They form a real structure, a mathematical order that affects what can happen next. So when we say possibility before fact, We do not mean mere ignorance. We do not mean that the universe knows the answer, and we simply do not. That would be an ordinary hidden fact. Quantum theory points towards something stranger. Before measurement, what exists may be a genuine field of possible outcomes not yet reduced to one actual event. This distinction matters because ignorance belongs to the observer. Possibility in quantum theory belongs to the system. If I close my eyes, while a coin lands on a table, the coin is still either heads or tails. My uncertainty changes nothing. That is classical ignorance. But a quantum system is not described that way. Before measurement, the issue is not simply that we do not know which result is real. The issue is that the system itself may not yet be in one definite classical state. That is why superposition is so difficult. It asks us to imagine a kind of reality that is not nothing, not illusion, not pure fantasy, but also not yet a single settled fact, a reality of structured potential, a reality that is real enough to influence outcomes, real enough to interfere, real enough to shape probabilities, yet not real in the ordinary sense of one final answer. This is the threshold where language begins to fail. Because ordinary language was built for completed events. A thing is here, a stone falls, a door is open, a path is left or right, but quantum systems before measurement do not always fit. That grammar, they are not well described as carrying one hidden sentence inside them. They are better described as holding a set of possible sentences, not yet collapsed into one, and that is why the old question changes. We no longer ask only, which path did the particle take? We now ask, was there a single path to begin with? Or was there, before measurement, something deeper than path? A state from which different paths could become actual? This is the philosophical wound, opened by quantum theory, because it forces us to separate two ideas we once treated as the same, real and actual. A thing may be real without yet being actual in one definite form. A possibility may be real if it has structure, consequence, and measurable effects. And quantum theory suggests exactly that. Before measurement, possibilities are not empty words. They have order, amplitude, phase, influence. They belong to the description of the world. Then measurement occurs and one possibility emerges as fact. One actual result, one event, one record. This is why measurement looks less like discovery and more like reduction, less like opening a box that already contains one finished answer, and more like forcing an unresolved state into one determinate outcome, not creating reality from nothing, but narrowing reality into fact. This is a subtler view and a more dangerous one, because if reality before measurement is possibility rather than fact, then the universe is not a static collection of fully defined objects. It is a layered order. At one level, there is quantum openness, at another, classical definiteness. At one level, many available outcomes. At another, the single event we experience. And the passage between those levels is where the mystery lives. This is why the question of reality cannot be answered too quickly. If we ask, does reality exist before measurement? The quantum answer may be yes, but not always as a finished fact. Yes, but as possibility, organized with extraordinary precision. Yes, but in a form less solid, less final, and less classical than human intuition expects. And once that is admitted, a deeper question appears. If possibility is real, what kind of thing contains that possibility? What is the form of a quantum system before measurement? What is the object, or perhaps not object, that physics uses to describe this strange realm between openness and fact? That question leads directly to the central symbol of quantum theory, the wave function, to describe a quantum system. Before measurement, physics uses one central idea, the wave function. It is one of the most powerful and most mysterious objects in science, because with it, Quantum theory predicts outcomes. With astonishing accuracy, it tells us how possibilities evolve, how probabilities shift, how interference appears, how measurement can yield one result instead of another. And yet, if for all its success, a deeper question remains. What is the wave function really? Is it something physically real? A true feature of the world? A hidden layer of reality beneath the objects we see? Or is it something else? A tool, a map, a compact way of expressing what can be known about a system? This question matters because everything changes depending on the answer. If the wave function is real, then quantum possibility is not just in our heads, it belongs to nature itself. Before measurement, the world would truly contain a structured spread of possible outcomes, not metaphorically, not as ignorance, but as part of reality. In that view, superposition is not a trick of description. It is how the world actually is, before fact becomes definite. But if the wave function is only a tool of knowledge, then quantum theory may not be telling us what reality is, only what we can say about it, only how to organize expectations about future results. In that view, that the wave function does not describe a strange, unfinished world. It describes our uncertainty, our information, our predictions, and this difference cuts to the center of the whole mystery. Because if the wave function is merely epistemic, a state of knowledge, then perhaps beneath it, there still exists a deeper, definite reality that quantum theory does not fully expose, a hidden world with sharper facts than the formalism admits. But if the wave function is ontic, a state of reality, then the quantum world is genuinely unlike the classical world. Then possibility itself belongs to being. Then before measurement, a system is not secretly classical. It is quantum all the way down. This is why the wave function is not just mathematics, it is a battlefield between two visions of reality. The first says, the world has definite properties beneath our uncertainty, and the wave function is only a useful summary. The second says, the wave function is part of what the world is, and definiteness emerges only later through measurement or interaction. Both views try to protect something important. The first protects realism in the classical sense, and the second protects the literal power of quantum theory, and neither side can be dismissed lightly. Because the wave function behaves in a peculiar way. It is not located in space the way a stone is. It is not visible. It is not something we detect directly, like a particle strike on a screen. Instead, it is a formal structure from which observable outcomes can be derived. That already makes it strange. It seems real enough to govern what happens, but elusive enough to resist ordinary ontology. It feels less like an object and more like a hidden architecture of possible events. And perhaps that is why it unsettles people. If the wave function is real, then reality includes something that is not made of small, solid pieces moving through empty space. It includes amplitude, phase, potential relation, a deeper order from which measurable facts emerge. That is a very different universe from the one human intuition was built to expect. And yet, if we refuse to grant reality to the wave function, another problem appears. Why does the theory work so well? Why does this mathematical object track the world with such precision if it corresponds to nothing real? Why should a mere bookkeeping device capture so much of nature's structure? That is why the question does not go away. The wave function may not be a physical object in the classical sense, but it may still be an element of physical reality in a deeper one. Not a thing, not a particle, not a field like those we imagined in older physics, but a rule-bearing structure that constrains what can become actual, a reality, not of finished objects, but of possible outcomes, ordered in advance by mathematical form. This is where quantum thought becomes difficult, because the wave function seems to live between two worlds, too powerful to be dismissed as fiction, too abstract To fit comfortably among ordinary things, it is like a shadow cast by a layer of reality we do not know how to picture. And so the central question sharpens. Before measurement is the wave function. What the system really is? Is that the form of quantum existence before fact, or is it only our best incomplete language for speaking about a deeper hidden state, physics even now that does not force one final answer? Different interpretations take different sides. Some say the wave function is real. Some say it represents information. Some say the distinction itself may be too crude. But one thing is certain: the wave function changes what existence means. Because if it is real, then to exist before measurement is not necessarily to possess one definite value. It may mean to exist as a structured openness, as a living set of possibilities governed by law, as something not yet reduced to one final event. And if that is true, then the next mystery becomes unavoidable. How does one definite outcome ever appear at all? How does this spread of possibilities become one fact? How does the unresolved become resolved? That is where quantum theory reaches its most dramatic word: collapse. If the wave function describes a spread of possibilities, then one question becomes unavoidable. How does one result ever emerge? How does a system described by many possible outcomes give rise to one actual fact, one click, one position, one recorded event? Quantum theory gives us two very different looking moves. First, that the wave function evolves smoothly, continuously, predictably. Its possibilities change over time. According to precise law, nothing in that evolution singles out one final answer. Nothing in it says this outcome alone must now become real. And then suddenly measurement occurs. And instead of many possibilities, we get one result. This sudden transition is what is called collapse. The word is simple, its meaning is not, because collapse seems to describe the moment when quantum openness gives way to classical fact. Before collapse, the spread of possible outcomes. After collapse, one actual event. Before superposition, after selection. Before many ways the world could answer. After one answer has entered reality. That is why collapse feels so dramatic. It appears to mark the birth of fact itself. And yet, the deeper one looks, the stranger it becomes. Because collapse does not fit naturally with the smooth evolution of the wave function. The ordinary equations of motion describe possibility unfolding. They do not clearly describe why one possibility alone should suddenly survive. So quantum theory seems to contain two different stories. One story is elegant, continuous, and mathematical. The other is abrupt, singular, and tied to measurement. That tension is the measurement problem. Not a technical detail, not a side issue, a fracture at the very center of the theory. Because what is collapse really? Is it a real physical event? Something that actually happens in the world? A genuine transition from many possibilities to one fact? If so, then where exactly does it happen? At what scale? Under what condition? When does possibility stop being possibility? When does fact begin? Or is collapse not something physical at all? Is it only a change in description? A change in what we know? A shift in information, not in reality? In that view, collapse would not mean that the world itself suddenly changes. It would mean that our account of the world becomes more specific once an outcome is known. This is the divide. Collapse as event, or collapse as appearance. Collapse is a real cut in nature, or collapse as a feature of how observers update knowledge. Both possibilities carry a price. If collapse is real, then physics seems to require a special process beyond ordinary evolution, a moment when the normal rules bend, a point where something exceptional occurs. That makes the theory harder to interpret. But if collapse is only apparent, then another burden appears. We must explain why the world feels so definite, why we never experience a blur of possibilities, why every measurement arrives as one result and not many, why fact feels singular if reality underneath never truly collapses. This is why collapse remains one of the deepest problems in modern thought, because it asks whether definiteness itself is fundamental or emergent, whether reality truly chooses or only seems to, whether the transition from possibility to fact is written into nature or written into us. And there is something else. Collapse sounds violent, as if possibilities are destroyed, as if reality narrows by force. But perhaps that language misleads us. Perhaps collapse is not destruction, perhaps it is resolution. Not the death of possibilities, but the appearance of one stable event within a structure that once allowed many. Still, even that softer language cannot remove the difficulty, because whether we call it collapse, selection, resolution, or actualization, the same mystery remains. Why this outcome? Why now? Why one fact instead of another? Quantum theory can tell us the probabilities. It can tell us the distribution of outcomes. It can tell us how likely each possibility is to appear. But probability is not actuality. A list of chances is not yet a single event. And sooner or later, the world produces an event. Not a cloud of maybes, a fact. That is the point where interpretation begins. Some will say, collapse is real, and some will say it never truly happens. Some will try to remove it entirely from the foundations of physics, but none of them can avoid the same demand to explain how the definite world we inhabit emerges from the indefinite structure quantum theory describes. That is why collapse is not a side effect, it is the point, where quantum mechanics stops being merely strange and becomes metaphysical. Because once collapse enters, we are no longer asking only how particles behave. We are asking how facts are born, how the world moves from openness to commitment, how reality stops hovering among alternatives and enters history as one determinate event. And if collapse is real, then reality may truly change in the moment of measurement. But if collapse is an illusion, then something even stranger must be true. The definiteness we experience may emerge without the universe ever making a single absolute cut. That is the next turning point, because the first great interpretation of quantum theory accepted the mystery, lived with it, and gave it a name. Not a solution, a stance, a way of speaking about reality. Only when reality has answered, that view became known as Copenhagen. The first major response to the quantum problem did not try to remove the strangeness, it tried to live with it. This response became known as the Copenhagen interpretation, not because it was one perfectly unified doctrine, but because it gathered around a shared instinct. Quantum theory does not describe a world of definite properties in the classical sense. Before measurement, it describes possibilities, probabilities, potential outcomes. And when measurement occurs, one of those outcomes becomes actual. In this view, the mistake begins when we ask too much of reality. Before interaction, we want to know where the particle really was, which path it truly took, what value it secretly possessed. Before the apparatus intervened, Copenhagen answers. That demand may be misguided, not unanswered, misguided, because quantum theory on this view is not obliged to provide a hidden classical story. Beneath observed events, it gives us a rule for predicting outcomes, and those outcomes are what physics is entitled to speak about. With confidence, this sounds modest, almost practical, but its implications are enormous because it shifts the center of reality away from hidden being and toward observable result. What matters most is not what the system was in itself before every possible interaction. What matters is what can be said once a measurement has produced an outcome. In that sense, Copenhagen treats physics less as a portrait of an unseen world and more as a disciplined language for relating preparation, measurement, and result. The wave function here is not necessarily a photograph of reality. It is a tool for organizing expectations, A formal structure that tells us what may happen when the world is questioned in a definite way. And once the question is asked, once measurement occurs, the answer becomes physical fact. This is why Copenhagen can sound both elegant and deeply unsatisfying. Elegant because it refuses to invent unnecessary machinery behind the theory. Unsatisfying because it seems to stop exactly where the hunger begins. The mind wants to ask, yes, but what was really there before measurement? Copenhagen often replies that that question may not correspond to anything meaningful. In physics, the particle did not necessarily possess a definite path before the experiment. Made path a real issue, the property did not necessarily exist in classical form before the apparatus forced a definite outcome. Reality in this view becomes speakable. At the moment, it becomes answerable. That is the heart of it. Before measurement, quantum theory offers a structured range of possibilities. After measurement, it offers one result. And physics should not pretend to own a deeper classical picture unless the theory actually provides one. This is not anti-reality, it is anti-excess. It says, do not smuggle into nature more definiteness than the formalism requires. Do not assume that the world is made of hidden classical facts simply because your intuition demands them. The discipline of physics in this view is to speak only, where the theory has earned speech. And yet the discomfort remains because Copenhagen seems to divide the world into two regions. On one side of the quantum system, described by probabilities, superposition, open possibilities. On the other, the classical apparatus, the measuring device, the recorded outcome, the definite fact. And the question immediately returns, where exactly is that boundary? At what point? Does the quantum become classical? At what point? Does possibility become event? Copenhagen can function without fixing that line, with perfect precision. But the philosophical mind is not satisfied by function alone. It wants ontology. It wants the world itself, not only the successful procedure. For predicting what appears, that is why Copenhagen has often been accused of surrendering too much. It preserves the power of quantum theory, but at a cost. It asks us to accept that reality before measurement may not be fully describable. In the terms we most trust, no definite path, no fixed value, no settled fact, only a formal structure from which facts emerge, when interaction makes them real, in the classical sense. This is why Copenhagen can feel at once sober and unsettling. It does not say, the world is illusion. It does not say, consciousness magically creates matter. It says something more disciplined and perhaps more radical, that physical meaning belongs to measurable outcomes, and that before those outcomes are classical categories may simply not apply. The particle is not secretly a tiny stone with a private itinerary. The system is not a hidden little world waiting for us to uncover its completed script. Before measurement, there is quantum structure. After measurement, there is fact, and the temptation to fill the gap with classical imagination must be resisted. For some, this is wisdom. For others, it is retreat, because one can always ask if physics refuses to describe reality before measurement. Indefinite terms is that because reality is genuinely indefinite, or because the theory is incomplete, that question did not go away, and it only grew sharper. And for those who could not accept, that reality becomes definite. Only at the point of answer, another path opened, a far more extravagant one, a path that kept the wave function, rejected collapse, and paid for certainty by multiplying reality itself. That path would become known as many worlds. For some physicists, Copenhagen asked, for too much surrender, it seemed to say, that before measurement, the world is not fully definite, and that after measurement, one outcome simply appears. Useful, yes. Predictive, yes. But not satisfying, because the deeper question remained, what really happens when a measurement occurs? Many worlds offers a brutal answer. Nothing collapses, nothing is cut, Nothing magical selects one single result. The wave function continues evolving, smoothly, always, without exception. That is the core idea quantum theory already provides, a continuous mathematical evolution. So why add collapse at all? Why break the law? Just because measurement happens? Why not take the equations literally all the way through? If we do that, something astonishing follows. When a quantum system interacts with a measuring device, the total system evolves into a larger superposition, not one result, all results. The particle does not choose one path. The apparatus does not record one unique answer. Instead, system and observer become entangled with every possible outcome. One branch contains this result. Another branch contains that result, and each branch is internally definite. This is the price many worlds is willing to pay. No collapse, but many realities. Or more carefully, many branches of one evolving quantum reality. In this view, measurement does not destroy possibilities. It separates them. What looked like collapse is only the observer, finding themselves inside one branch of a larger structure. You do not witness all outcomes at once because your own state is part of the branching. You become correlated with one result. Another version of you is correlated with another. From inside any one branch, the outcome feels singular, a fact, a definite event. But globally, the wave function still contains them all. This is why many worlds is both elegant and overwhelming. Elegant because it removes collapse. It keeps the mathematics clean, no special exception. For measurement, no mysterious jump from possibility to fact, only one rule and applied universally. But overwhelming because the cost is enormous. Reality does not narrow to one history. It proliferates into many. Every measurement-like interaction that could produce alternatives becomes a branching of the universal state. Not one world choosing, a world dividing, or perhaps better, a universal structure, differentiating into mutually inaccessible branches. This changes everything, because in many worlds, the question, which outcome becomes real, has a new answer, all of them, each in its own branch, each fully real, within its own line of experience, each containing observers who perceive a definite result and naturally believe that one answer alone occurred. That is why the interpretation is so unsettling. It preserves definiteness locally by abandoning uniqueness globally. You keep fact, but lose singular reality. You keep order, but multiply existence. And yet, many worlds has power. It explains why collapse looks real without requiring an actual collapse. It explains why we see one result without claiming that one result alone exists. It turns measurement into branching correlation, not physical reduction. In this picture, the wave function is real, fully real, not a tool of knowledge and not a bookkeeping device. It is the deep structure of the world, and what we call the classical world is only one stable branch. Within that structure, a local island inside a larger quantum sea. But new questions appear. If all outcomes occur, what becomes of probability? Why should one branch feel more likely than another? If all are real, what does it mean to say an outcome has a 70% chance if every possible result is realized somewhere? This is one of the great tensions inside many worlds. It saves the equations, it removes collapse, but it forces us to rethink chance and identity and even selfhood. Because if branching is real, then after measurement, there is not one future you. There are many successors, each carrying forward a different version of the event. And each one from the inside, what feels unique, feels singular, feels like the continuation of the same self. This is where physics touches metaphysics again. What is a world? What is a person? What is a fact if every possible fact is realized somewhere in the branching structure of reality? Many worlds answers. With radical consistency, reality does exist. Before measurement, it exists as the wave function. After measurement, reality does not collapse and it differentiates. Not one answer emerging from many possibilities. but many answers, becoming separately real in different branches. For some, this is unbearable excess. For others, it is the most honest reading of the theory. No hidden variables, no special collapse rule, no retreat from the math. Only one quantum reality taken seriously. And yet, many found the cost too high, too extravagant, too ontologically vast. They wanted another path, one that preserved a definite world without multiplying universes. One that said, the particle really does have a position, a path, a concrete history. Even before measurement, that path would return realism to quantum theory, but at a different price. Not many worlds, but hidden order. That is where we meet Bohm. Many worlds kept the equations clean, but it multiplied reality. For many, that price was too high. They wanted something else, not collapse, not branching worlds, but a deeper order beneath quantum appearances. An order in which particles are real, positions are real, and the world remains definite. Even before measurement, this is the path, opened by de Broglie-Bohm theory, is often called pilot wave theory. Its central claim is simple and radical. A particle really does have a position at every moment, not sometimes, not only when measured, always. The electron is not merely a cloud of possibility waiting to become real. It is real already. It has a location. It follows a path. So in one sense, Bohm restores what quantum theory seemed to take away. Reality exists before measurement. The particle is there. The world is definite. But Bohm does not return to classical physics unchanged, because the particle is not alone. It is guided by the wave function. This is the second half of the theory. The wave function is real, but not as a mere list of possibilities. It acts more like a guiding structure, a quantum field of order that directs how particles move. The particle has a position. The wave guides the motion. Together, they produce the strange behavior. Quantum experiments reveal this is why the theory is called pilot wave. The wave does not replace the particle, it steers it. In the two-slit experiment, for example, the particle passes through one slit, not both, one, but the guiding wave passes through both. The wave interferes with itself, and that interference shapes the trajectory of the particle. So the final pattern on the screen still appears, but now there is a hidden story underneath, a real path, a real particle, a real trajectory guided by a deeper order we do not directly observe. For the classical mind, this feels like relief. At last, a particle truly goes somewhere. At last, a measurement is not the birth of reality, but the revelation of what was already the case. And yet, the relief does not come free, because Bohm's theory preserves definiteness. By introducing something quantum physics had already made unavoidable non-locality. In Bohm's universe, the guiding wave can connect distant events in a way classical intuition cannot tolerate. The behavior of one particle may depend on the total quantum state, including relations that stretch across space. The world remains definite, but it is no longer local in the old sense. Reality is restored, but locality is wounded. This is the trade. Copenhagen protects practical humility. Many worlds protects continuous evolution. Bohm protects definite reality, but pays with hidden order and deep non-local connection. And that makes Bohmian mechanics both beautiful and eerie. Beautiful because it gives a coherent ontology. There are particles, there are paths, there is a real world beneath measurement. Eerie because that world is guided by something we cannot picture as ordinary matter. The wave function here is not just information, it is active. It shapes motion. It carries form. Without being a classical force, it is less like a push and more like an invisible instruction, a silent architecture that tells matter how to move. This is why Bohm's universe can feel almost ancient and futuristic at once. Ancient because it restores a hidden reality beneath appearances. Futuristic because that hidden reality is stranger than the one it replaces. The particle has a path, yes, but the path is guided by a non-local order that ties the world together beyond ordinary space. And so the question changes again. Does reality exist before measurement? Bohm answers, absolutely, not as mere possibility, not as branching worlds, but as a definite configuration of particles, moving under the guidance of a deeper quantum law. Measurement does not create the path, it reveals it. Measurement does not produce the particle's position, it uncovers what was already real. This is one of the strongest, realist answers to the quantum problem, and yet even Bohm does not make the mystery disappear, because although it restores a definite world, it leaves us with a new unease. If the particle always had a path, why can we not know it directly? If the world is definite, why must its deepest order remain hidden? And if the wave guides the particle, what exactly is the wave itself? A field, a law, a structure beyond space? As we understand it, Bohm rescues reality, but in doing so, he reveals that realism itself may require a universe more subtle than classical thought ever imagined. A world that is definite, yes, but quietly interconnected at depths we do not see. And still, one question remains dangerous. Even if particles have paths, what role does observation play? Why does measurement still seem so central to what becomes visible, recorded, and known? Because sooner or later, every interpretation must face the same shadow, the observer. Sooner or later, on every path through quantum theory arrives at the same dangerous word, observer. And the moment it appears, confusion follows. Because in ordinary language, an observer means a conscious being, a person, a mind, someone who sees, someone who knows. So when people hear that quantum physics gives a special role to observation, they leap to a dramatic conclusion. The mind creates reality, but that move is too fast and usually too crude. In physics, an observer does not have to be a human being. It does not even have to be conscious. An observer in the quantum sense is often just a physical system. That becomes correlated with another one, a detector, a measuring device, an environment, anything capable of producing a definite record. That distinction matters because if measurement requires only physical interaction, then reality does not wait. For human eyes, it does not need a scientist in a lab coat to become real. A photon striking an atom disturbing a detector leaving a mark. These may already be enough to count as observation in the physical sense. And yet, the shadow of consciousness does not disappear so easily, because even if physics does not require a mind to collapse reality, the very language of measurement still points toward knowledge, record, and experience. A result is not just a microscopic event, it is something that becomes definite, distinguishable, available as fact. And sooner or later, all fact enters some chain of awareness. Someone reads the dial, someone sees the screen, someone says, this happened. That is why the observer remains unsettling, not because consciousness must be magical, but because quantum theory forces us to ask, what kind of world exists before a result becomes part of an experienced reality? Some thinkers went further. They suggested that consciousness itself might play a special role, that the physical chain is not enough. That possibility becomes fact only when a result enters awareness. This is one of the most famous and most controversial ideas ever associated with quantum mechanics. It is also one of the easiest to misuse because it can quickly turn into slogan, mysticism, or wishful fantasy. Quantum physics does not say that human thought freely invents the world. It does not say that belief overrides law. It does not say that the universe is a dream waiting for your attention. Those are distortions. Still, the temptation exists for a reason, because the observer problem does expose a genuine crack. If physical interaction alone is enough, then where exactly Does definiteness arise at the first microscopic contact, at the detector, at the amplification of the signal, at the moment a stable record is formed, or only when a conscious being becomes aware of the record? Each answer draws the boundary in a different place, and none of them feels entirely safe. If consciousness is necessary, then mind seems woven into the structure of fact. If consciousness is unnecessary, then we still must explain how a purely physical process produces a world that appears definite to consciousness in the end. So either way, that the problem returns not necessarily as magic, but as depth. The observer, then, is not simply the creator of the world, nor is the observer irrelevant. The observer marks the place where quantum possibility and lived reality meet, the point where a physical process becomes a fact inside a chain of record, relation, and eventually experience. Now, this is why the question is so persistent. Does the observer create the world? Probably not in the naive sense. But does the observer stand outside the problem? No, because whatever else is true, the world we call reality is not just the world. That may exist in theory. It is the world that becomes definite enough to be entered, registered, unknown. That difference changes everything. The observer may not be the author of reality, but the observer belongs to the drama through which reality becomes fact. And once we admit that, a deeper paradox appears. What happens if one observer has already seen a result, while another observer still treats the entire situation as unresolved? What if fact itself depends on perspective? What if one observer's certainty is another observer's superposition? That is where the question of the observer stops being merely unsettling and becomes explosive. Because now we are no longer asking whether observation matters. We are asking whether a fact for one mind is always a fact for every mind. And that question leads to one of the strangest thought experiments in all of quantum theory, Wigner's friend. Imagine a sealed laboratory. Inside it, a scientist performs a quantum measurement. A detector clicks. A result appears. From the scientist's point of view, the event is finished. A fact has occurred. The particle was found in one state rather than another. The outcome is known. Now imagine another observer outside the lab. This observer has not yet looked inside, has not seen the result, has not interacted with the scientist or the record. From the outside, the entire laboratory, the particle, the detector, the scientist, the written result can still be treated as one larger quantum system. And this is where the trouble begins. For the scientist inside, the measurement is complete. For the observer outside, the system may still be described as a superposition, not just of particle states, but of the whole situation. One branch in which the scientist saw one result, another in which the scientist saw another. One observer says, a fact exists. The other says, the total system is still unresolved. This is the thought experiment, known as Wigner's friend, and it strikes at something even deeper than measurement alone. It strikes at the meaning of a fact, because what we usually call a fact is supposed to be final, stable, and objective, the same for everyone. If a detector clicked, then it clicked. If a result was recorded, then it was recorded. What could be more basic? But Wigner's friend forces a terrifying possibility. What is definite for one observer may remain indefinite for another. What is an outcome inside the lab may still be part of a quantum superposition outside it. So whose description is real? The friend's, Wigner's, both, neither? This is not a minor puzzle, and it threatens the classical idea that facts are absolute, because if one observer can consistently say, the result has happened, while another can consistently say, the total system is still in superposition, then reality begins to fracture along lines of perspective, and that is almost intolerable to ordinary reason. We can accept that particles are strange. We can even accept that measurement is subtle, but to question whether facts themselves are observer independent, that is far more dangerous. It suggests that objectivity may not be as simple as we thought. Some try to escape by saying the outside observer should not really treat the whole lab quantum mechanically. At some point where they argue collapse must already have taken place, the friend saw the result, the fact is fixed, end of story. But others insist that if quantum theory applies universally, then the outside description must be taken seriously too. And if it is, then the paradox returns, because quantum theory seems to allow both descriptions to stand, one fact inside, one superposition outside. That is why Wigner's friend is so destabilizing. It does not merely ask whether measurement creates reality, it asks whether reality itself must always be the same for every observer, whether a fact is truly absolute or relational, whether the world contains one final story or many valid standpoints that cannot be collapsed into a single classical picture. This thought experiment does not prove that reality is subjective. That would be too easy, too careless. But it does suggest that the structure of fact may depend on how systems relate to one another, on who has interacted with what, on where the boundary of correlation has been drawn. And once that possibility appears, the old dream of a God's eye view begins to weaken. Maybe there is no single vantage point from which all facts are already settled in one complete classical order. Maybe what is definite emerges locally and within networks of interaction. Maybe fact is not simply found once and for all, but established relative to physical relations. If that is true, then objectivity must be rebuilt from something deeper than absolute hidden facts. And that leads to the next interpretation, one that accepts this wound directly, one that asks whether reality itself may be made, not of isolated things, but of relations, not absolute properties, but interactions, not a world of facts, floating free of perspective, but a world in which what exists is always tied to what it exists for. That is where quantum theory turns again toward relational reality. After Wigner's friend, the old idea of objectivity begins to crack, not because facts disappear, not because reality becomes mere opinion, but because quantum theory seems to suggest that facts may not exist in the same absolute way for every possible observer at once. This is where relational quantum mechanics enters. Its proposal is radical but precise. A physical property does not necessarily exist as an absolute feature of a system all by itself. It exists relative to another system with which it interacts. In other words, there may be no view from nowhere, no final inventory of properties written into the universe, independent of all relations. Instead, what is real is what becomes definite in an interaction. A fact is not simply a thing floating in space. It is a fact for something, for a detector, for an observer, for a system that has entered a physical relation with another. This is the key shift. Classical thought assumes that objects carry their full properties inside themselves. Massachusetts, position, velocity, state. The world is imagined as a collection of self-contained things. Relations come later. Quantum thought in this relational form reverses the order. Relations come first. Definiteness emerges. In the meeting, a system is not required to possess all properties, absolutely, for all observers. Before every interaction, it acquires physical meaning through interaction itself. That is why Wigner's friend becomes less paradoxical. From this point of view, the friend inside the lab has interacted with the system. For the friend, the result is definite. Wigner outside the lab has not yet entered that chain of interaction. For Wigner, the larger system may still be described as unresolved. These are not necessarily contradictory realities. They are different relational facts, different accounts, grounded in different physical connections. This does not mean anything goes. It does not mean truth becomes arbitrary. A relation is not. A private fantasy, it is a real physical interaction. A detector clicks, a record forms, a system becomes correlated with another that is objective. Within the relation, what changes is not seriousness. What changes is absoluteness. Relational reality says facts are real, but not always global. Definiteness exists, but not necessarily from every perspective at once. And this is both elegant and unsettling. Elegant because it removes the need for a single, God's eye story in which every property must already be fixed for all systems everywhere. Unsettling because it asks us to abandon one of the deepest habits of thought, the belief that reality is fully complete in exactly the same way for every possible witness. In a relational universe, the world is not a silent warehouse of finished properties. It is a web, a network of interactions, a structure in which facts arise at points of contact, not illusion, not subjectivity, but event-based reality. Reality as answered relation. This helps explain why the observer problem feels so persistent. The problem was never simply that observers exist. It was that facts seem to depend on chains of interaction. Relational quantum mechanics takes that dependence seriously. It says, yes, that may be exactly what reality is like. A property is not merely there in itself. It is there for another system in a definite physical context. This is a profound change in metaphysics because it means that being may not be primary in the old sense. Relation may be primary. What exists is not first. A self-enclosed object. What exists is a node within a world of exchanges, a term within a structure of events, a bearer of properties only insofar as those properties become meaningful in interaction. And once this is said, the universe looks different, less like a stage filled with objects, more like a living geometry of encounters, less like finished substance, more like relational becoming. This idea has great power. It preserves reality without forcing all facts to be absolute at once. It preserves measurement without making consciousness the magician of the cosmos. It preserves definiteness where interaction occurs without demanding that every unobserved relation already carry the same completed status, but the unease remains. Because the world does not feel relational, it feels solid, stable, shared. Tables do not seem to depend on perspective in any troubling way. The moon does not appear to change its status because one observer looks and another does not. The classical world feels unified, public, common. So the next question becomes unavoidable if reality is relational. At the quantum level, why does the everyday world appear so definite and so universally stable? Why do possibilities not remain visibly open? Why do macroscopic objects not behave like unresolved superpositions? Why does the world look classical if its foundations are quantum? To answer that, quantum theory turns to one of its most important ideas, not collapse, not hidden variables, not branching worlds, but decoherence. The quantum world seems open. The everyday world does not. At small scales, systems can exist. In superpositions, alternatives remain active. Possibilities interfere. But at human scales, things look settled. A chair is here, a glass falls, a planet follows. A stable orbit. The world appears definite, shared, and stubbornly classical. So the question becomes urgent. If quantum theory lies beneath everything, why does everything not look quantum? Why do we not see cats in superposition, tables in interference, or cities suspended between outcomes? This is where decoherence enters, not as a final answer, but as a powerful one. The core idea is simple. A quantum system never exists in isolation for long. It interacts with its environment, with air, with light, with heat, with surrounding matter, with countless degrees of freedom, too numerous to track. And through those interactions of the delicate relations that allow interference, begin to spread outward, the system becomes entangled with the environment. Its quantum possibilities leak into the world, and once that happens, the clean interference that defined the isolated system becomes effectively inaccessible, not destroyed exactly, but dispersed, buried, washed into complexity. This is decoherence. It explains why some superpositions become impossible to observe at large scales, not because quantum law switches off, not because reality stops being quantum, but because the environment constantly monitors, records, and entangles. The world is never still enough for large superpositions to remain clean. Now, that is why classical appearance emerges. A macroscopic object is not outside quantum theory. It is drowning in interaction. Its possible states are being entangled with the environment so rapidly that interference between alternatives is effectively erased from experience. So the world begins to look definite, stable, solid, not because quantum possibility has vanished from the foundations, but because the conditions required to see it directly have collapsed into noise. This is a profound achievement. Decoherence explains why the classical world appears at all, why measurement outcomes become stable, why detectors produce records, why macroscopic systems do not behave like pristine quantum waves drifting in isolation. It shows how the environment itself helps create the appearance of fact, and yet something remains unresolved, because decoherence explains why interference disappears from our practical view. But does it explain why one outcome alone is experienced? That is the deeper issue. Decoherence tells us why alternatives stop visibly mixing. It tells us why certain states become robust, why some outcomes can function as classical records. But does it tell us why this record, rather than that one, becomes the fact we live through? Not completely. That is why decoherence is so important and yet not sufficient for everyone. It solves part of the measurement problem, a major part. It explains the emergence of classical behavior from quantum interaction, but many argue that it does not fully explain actualization itself. It explains why branches stop interfering. It may not explain why one branch is the world of experience. This is the subtle distinction decoherence gives us. Effective classicality, it gives us. The appearance of collapse, it gives us. Stable records, shared environments, and the practical death of visible superposition at large scales. But whether it gives us a single final fact, that remains contested. Still, its philosophical force is enormous because it changes how we think about reality. The classical world is no longer the basic world. It is the world that emerges when quantum openness is constantly filtered through environmental interaction. Solidity is not fundamental, it is stabilized appearance. Definiteness is not the primitive layer, it is what survives the storm of entanglement. The world feels fixed because only certain patterns remain coherent enough to persist. Only certain states become durable, recordable, shareable, and that means the reality we inhabit may be less like a rigid inventory of objects and more like a set of stable patterns selected by interaction. This is a quieter revolution than collapse, less dramatic than many worlds, less metaphysically bold than Bohm, but in some ways it is more transformative because it suggests that the familiar world is not what reality is. At the deepest level, it is what reality looks like. After endless contact with itself, after the environment has done its work, after possibility has been sculpted into robust appearance, and if appearance itself depends on which distinctions can survive, which records can persist, which correlations can spread, then perhaps the deeper layer of reality is not matter alone. Perhaps it is information, not information as human meaning, but information as difference, correlation, record, distinguishable structure. And once that thought appears, the question changes again. Maybe the foundation of reality is not simply what exists. Maybe it is what can be distinguished, what can be recorded, what can be made definite through relation, which leads us to the next possibility that before matter becomes fact, there may be information. After decoherence, a new thought emerges. Maybe reality is not built first from solid things and only later described by information. Maybe the order runs deeper than that. Maybe what matters most is not substance alone, but distinction, difference, correlation, record. In ordinary language, information sounds human. It sounds like language, meaning messages, ideas in a mind. But in physics, information can mean something more basic, a difference that can be registered, a state that can be distinguished from another state, a relation that can persist, a pattern that can be copied, stored, or transferred. In that sense, information is not just what someone knows, it is what the world makes possible. Through structure, a mark on a detector is information. A spin aligned one way rather than another is information. A photon leaving a trace is information. A physical difference that can enter a chain of record is information. And once we see that, measurement itself looks different. It is not merely the passive reading of an already finished world. It is the formation of a stable distinction. Before measurement, there may be a spread of possibilities. After measurement, one distinction becomes durable. One difference enters the world as record. One outcome can now be told apart from the others. This is why information starts to feel more fundamental than matter alone. Because matter to matter must take form. It must possess distinguishable states. It must be able to enter relations, leave traces, and generate consequences. A world with no distinctions would be a world with no facts, no events, no history, no way for anything to become definite. So perhaps what we call a fact is not just a thing that exists, it is a distinction that has become stable enough to survive, a difference that can be recorded, a relation that can enter the shared structure of reality. This idea changes the question again. We once asked, does reality exist before measurement? Then we asked, does possibility become fact through interaction? Now we can ask something even deeper. What exists before distinction occurs? If measurement creates a stable difference, what is a quantum system before that difference is fixed? Is it already a definite physical state hidden from us? Or is it something less classical, a structured openness, not yet divided into one recorded answer? This is where information becomes powerful, because it gives us a way to speak about reality without reducing reality to tiny hard objects. Instead of asking which little thing is secretly where, we ask what distinctions are available, what correlations can form, what records can survive, what patterns can become stable enough to count as fact. In this view, the world is not merely a collection of particles. It is a fabric of possible distinctions, a field of relations waiting to become actual records. Matter remains real, energy remains real. But what gives them physical meaning is not brute presence alone. It is their capacity to enter structure, to be different, to be linked, to become detectable, to leave a trace. That is why some of the deepest voices in modern physics have been drawn toward the language of information, because quantum theory keeps returning to the same threshold, not just what is there, but what can be known. Through physical relation, not just being, but distinguishability. Not just existence, but recorded difference. And this does not reduce the universe to a spreadsheet of symbols. It does something subtler. It suggests that physical reality may be built from the capacity for events to become definite. That what is fundamental is not finished objecthood, but structured possibility, plus the conditions under which one distinction becomes real. This helps explain why measurement feels so central. Measurement is not important because humans care. It is important because it creates or stabilizes distinction. It turns openness into a record. It makes one outcome physically available as fact, and once a distinction is stable enough, it can spread into an apparatus, into an environment, into memory, into history. That is what a fact is. Not merely something that happened, but something that happened in a form that can endure. This is why information may stand closer to the root of reality than our classical instincts would like to admit. Because before solidity, that there must be form. Before form, difference. Before difference, a structure within which difference can arise. And quantum theory keeps pointing us toward that deeper level, a level where reality is not absent. Before measurement, but not yet cut into the fixed distinctions that classical thought demands. A level where possibility is real, but not yet exclusive. Where alternatives exist, not as ignorance, but as unresolved structure. Where what is fundamental may be less like a thing and more like an ordered capacity for distinctions to emerge. If that is true, then the unmeasured world is not a blank, it is not nothing. It is a deeper kind of physical openness, a prefactual order from which facts can be drawn. And once we allow that, the question grows larger, not just larger than the lab, larger than particles, detectors, and human observers. Because if measurement is about distinction, record, and physical relation, then what about the universe? Before life, before memory, before witnesses, before any mind ever asked a question, what was reality then? Was the early universe already definite? Did cosmic structure itself perform the work of measurement? Or did the universe too begin in a form less settled than the world we now inhabit? That is where the problem turns cosmic, toward the oldest reality of all, the unmeasured universe. The question now leaves the laboratory, it leaves the detector, the screen, the sealed room, the observing mind. It turns outward, toward the largest scale of all, the universe itself. Because if measurement is tied to distinction, record, and interaction, then one problem becomes impossible to avoid. What was reality before observers existed? Before eyes, before brains, before memory, before language, before any living being could ask a question about the world? Did the universe still exist? Common sense says yes, without hesitation. Stars burned before anyone saw them. Galaxies formed before consciousness emerged. Matter moved, collapsed, heated, expanded, long before life appeared on Earth. And physics itself depends on that confidence. The early universe is not treated as fantasy. It is treated as real history, a real past from which the present came. So if quantum theory seems to make measurement central, we must be careful. It cannot mean that the cosmos waited for human beings to arrive before becoming real. That would be absurd. And yet that the problem does not disappear, because quantum theory still asks, what counts? As measurement, what counts? As a record, what turns possibility into stable fact? If not minds, then what? The answer may be simpler and deeper than the mind first expects. The universe did not need humans in order to interact with itself. Long before observers, there were collisions, radiation, scattering, gravitational clumping, fields affecting fields, particles entangling with other particles, light leaving traces in matter, matter shaping the paths of light. In other words, the cosmos was not unmeasured in the sense of being untouched. It was full of physical interactions, full of distinctions forming, full of records written into structure. A star does not need a witness to fuse hydrogen. A planet does not need a mind to leave gravitational effects. An atom does not need a philosopher to absorb a photon. The universe can register itself, and this may be enough to rescue realism without returning to naive classical thought, because perhaps measurement was never about human awareness. Perhaps it was always about physical correlation, about one part of reality becoming definite for another, about events leaving marks in the fabric of the world. In that sense, the early universe was not empty of measurement. It was a vast cascade of mutual registration, a world becoming definite through its own interactions. And yet the mystery remains, because even if the cosmos measures itself, the deeper issue survives. Was the universe, before those interactions, already fully definite in every detail? Or did the early cosmos also exist in a more open form, structured, real, law-governed, but not yet fully classical in the way the later universe appears? This is the harder thought. Not that reality needed humans, but that reality itself may have undergone a transition from quantum openness to classical stability as the universe evolved, not from unreality to reality, but from indeterminacy to robust structure, from possibility to large-scale fact, from a deeply quantum order to the familiar world of stars, planets, rocks, and bodies. If so, then the early universe was not less real. It was differently real. Real but less settled. Real but not yet carved into the durable classical distinctions that later emerged. That idea changes the emotional meaning of cosmology. The beginning of the universe is no longer merely the start of matter and time. It may also be the gradual birth of definiteness, the slow hardening of a world, a cosmos in which interactions multiplied, records accumulated, structures stabilized, and reality became more and more classical without ever ceasing to be quantum underneath. This is why the unmeasured universe is such a powerful idea, because it forces us to let go of two bad options. First, the childish idea that consciousness must magically create the cosmos. Second, the equally childish idea that quantum theory changes nothing important about what existence means. The deeper path lies between them. Reality existed before minds, but perhaps not always, as a world of fully settled classical facts. Reality may have been real before observers, yet still open, in ways classical intuition cannot easily picture. A real universe, a dynamic universe, a self-interacting universe, a universe becoming definite through relation. And once we say that, physics can no longer avoid philosophy, because now the question is no longer just scientific, it becomes ontological. What do we mean by exist? If something can be real without yet being fully actual in one fixed classical form, what kind of being belongs to possibility? What kind of reality belongs to potential before it becomes fact? To go further, we have to stop speaking only about experiments, particles, records, and cosmic history. We have to ask the most ancient question with new seriousness: what does it mean to exist at all? Up to this point, the question has sounded physical: measurement, wave functions, collapse, observers, decoherence, the early universe. But now the problem changes shape, because underneath every quantum argument, there is an older question: what does it mean to exist? We often think the answer is obvious. To exist means to be there, to be real, to be something rather than nothing. But that clarity begins to dissolve the moment quantum theory forces us to distinguish between possibility and fact. Because classical intuition treats existence as all or nothing, a thing either is or is not. A particle either has a position or it does not. A property either belongs to an object or it does not. This way of thinking feels natural, but quantum theory presses against it again and again, and it suggests that reality may not fit inside such a simple frame. Something may be real without being classically definite. Something may exist without yet being actual in one final form. And once that possibility appears, existence itself stops looking simple. Perhaps to exist is not always to be fully determined. Perhaps being comes in layers. At one level, there is potential. At another, actualization. At one level, a structure of allowed possibilities. At another, one realized event. This is not mere wordplay. It changes everything, because if existence can include possibility, then the world before measurement is not empty, it is not fiction, it is not nothing, it is a real order that has not yet narrowed into one completed fact. That sounds strange, only because we are used to the language of finished things. A chair exists, a star exists, a stone exists. These are stable objects in a classical world, but quantum theory may be telling us that such stability is not the first form of being. It may be the later one, the hardened one, the visible one. Beneath it, there may be a more subtle kind of existence, not the existence of a final object, but the existence of an open structure from which objects and events can emerge. This is where philosophy quietly returns. Long before quantum mechanics, thinkers argued about potentiality and actuality, about whether something could be real as a capacity before it was real as an event. A seed is not a tree, but it is not nothing. It contains a directed possibility, a form of being that has not yet ripened into full manifestation. Quantum theory is not the same idea, but it forces a similar humility. It reminds us that the world may not be exhausted by what is already settled. Existence may include what is poised to become, what law allows, what structure sustains, what interaction can bring into fact. And this is why the measurement question cuts so deep when we ask whether reality exists. Before measurement, we are not only asking about physics, we are asking whether existence requires completed definiteness, whether being must already be fact, or whether being can also include a domain of real possibility prior to fact. This is the turning point. If existence means classical definiteness only, then the quantum world, before measurement, looks incomplete or less than fully real. But if existence can include structured openness, then the quantum world, before measurement, is not incomplete at all. It is simply not yet classical, not yet singular, not yet reduced to one history, one position, one record. That distinction matters because it rescues the question from a false choice. The choice was never either reality is fully formed before measurement or nothing exists. That was too crude. The deeper choice is this: either reality before measurement is already classical and secret, or reality before measurement exists in a different mode. Real, ordered, constrained, but not yet finalized as one actual fact. That second possibility is harder to imagine, but it may be closer to truth, because the world need not be empty until it becomes definite. It may be rich before it is final, real before it is singular, structured before it is decided. And once we say that, even the word object begins to change. Perhaps an object is not the most basic unit of reality. Perhaps the more basic level is event, relation, possibility, transition. Perhaps things do not come first. Perhaps becoming does. This would explain why quantum theory so often resists our attempt to picture the world as a hidden warehouse of miniature objects with permanent labels. The theory behaves more like a grammar of emergence, a discipline governing how possibilities unfold, interfere, stabilize, and enter fact. And that means the question of existence cannot be separated from the question of experience, because however reality exists, before measurement, human life is lived. After definiteness appears, we do not inhabit a blur of possibilities, we inhabit outcomes, memories, records, shared events, a world that has already become sharp enough to be suffered, loved, and known. So the next question cannot be avoided. If existence can stretch from possibility to fact, what role does consciousness play in that passage? Does mind matter? Only because it witnesses what has already become definite? Or is there something about conscious experience itself that belongs to the mystery of how a world becomes real? That is where the problem turns inward toward the most intimate and most dangerous idea in the whole story, consciousness. Now the question turns inward, not toward particles, not toward detectors, but toward the thing through which all questions are finally felt, consciousness. This is where the quantum story becomes dangerous, because once people hear that measurement matters and that observation seems important, a familiar claim appears. Consciousness creates reality. It is a powerful sentence, simple, provocative, almost irresistible, and yet it is also too simple. Quantum theory does not require that human awareness magically manufacture the world. Electrons did not wait for brains to evolve. Before behaving quantum mechanically, stars did not need witnesses to ignite. Galaxies did not remain in limbo until minds appeared. Reality is older than thought, older than memory, older than every eye that has ever opened. So if consciousness matters, it cannot matter. In that crude sense, it cannot be the private author of the cosmos. That idea is too narcissistic, too small for the scale of reality. And yet consciousness does not disappear from the problem, because even if measurement can occur through physical interaction alone, consciousness remains. The place where a world is not merely recorded, but lived. A detector can register a value. A screen can display a mark. A memory chip can store a signal. But none of those things by themselves tell us what it is for reality to appear, to be present, to be experienced as an actual world. Now, this is the subtle point. Physics may not need consciousness to produce a measurement, but philosophy cannot so easily remove it from the meaning of fact, because a fact is not only something that enters a record, it is also something that can enter awareness. A world without consciousness might still contain events, correlations, and interactions and structure, but consciousness introduces something new, the felt presence of the real, not just information, experience, not just distinction, appearance, not just record, a world for someone. This is why the question persists, not because minds must collapse wave functions, but because consciousness marks the point where the universe is no longer only happening, it is given, seen, suffered, known from within. That does not make mind the creator of matter, but it may make mind the place where reality becomes more than process, more than external relation, more than physical transition. Consciousness is strange for another reason too. It is the one thing we know, not from theory first, but from immediacy. We infer particles, we model fields, we calculate wave functions. But consciousness is encountered directly. Before every equation, before every instrument reading, before every interpretation, there is the fact that something is appearing to awareness. And that means the measurement problem cannot completely ignore it, even if consciousness is not the trigger. That selects outcomes, it remains bound to the deepest mystery, why there is a definite world appearing at all instead of a chaos of unresolved possibility. Some thinkers wanted to go further. They argued that consciousness must play a decisive role, that until an experience occurs, physical processes remain incomplete, that awareness itself is the final boundary between possibility and fact. This view is famous, it is seductive, and perhaps too confident, because it risks explaining one mystery by placing inside it another mystery. We understand even less. To say consciousness causes collapse may sound profound, but unless we know what consciousness is and how it acts on matter, the statement may only rename the problem. Still, it points to something real, not a mechanism perhaps, but a tension between physical description and lived reality, between the world as formal structure and the world as present experience. Quantum theory sharpens that tension. It tells us that reality beneath appearance may not be a world of finished things, but consciousness knows only finished appearances. This sound, this light, this memory, this grief, this breath, We do not live in amplitudes, we live in outcomes. And that is why consciousness matters, even if it is not the engine of collapse. It matters because it is the interior side of definiteness, the inward face of fact, the place where one branch of reality, however it emerged, becomes a world. So is consciousness necessary? Not necessarily. For quantum events to occur? Not necessarily. For stars to burn, atoms to scatter, or fields to interact. But perhaps necessary for something else, for reality to become experience, for fact to become presence for the universe, not merely to happen, but to be given from within. That is already enough to make consciousness impossible to dismiss. Because even if mind does not create the world, it receives the world in a way nothing else we know does. And in receiving it, it transforms event into meaning, record into memory, outcome into history, which leads to another question. One just as deep: if facts become part of an experienced world, through memory, through record, through persistence in time, then what exactly is the relation between measurement, time, and the birth of a fact? When does an event stop being a possibility and begin to belong to history? That is where the problem turns again toward time, memory, and the making of the real. A possibility is not yet a history. A probability is not yet an event. A quantum state may contain many outcomes, but lived reality does not arrive as a cloud. It arrives as a fact. Something happens, something remains, something can be remembered. This is where time enters the problem, not just as clock time, not as seconds, falling one after another, but as the medium through which a result becomes irreversible. Before measurement, a system may be described by alternatives. After measurement, one outcome stands. But even that is not the whole story, because for a fact to become fully real, in the world we inhabit, it must do more than simply occur. It must persist. It must leave a mark. It must survive long enough to enter a chain of consequence. This is why memory matters. Not only human memory, physical memory, a detector state, a trace on a screen, a change molecule, a signal in a circuit, a pattern in the environment. A result becomes a fact when it does not vanish without residue, when it enters time, when the world is no longer the same after it happened. That is the deeper meaning of record. A record is not mere storage. It is physical commitment, evidence that one path through possibility has hardened into history. This is why measurement feels so close to the birth of a fact, because measurement is not only selection, it is stabilization. One outcome is not just chosen, it is retained, amplified, written outward, made durable enough to become part of the future. And once that happens, time acquires direction, not because clocks suddenly begin, but because the world now contains an asymmetry. Before the event, multiple futures were open. After the event, one past exists. That is the arrow hidden inside fact. The movement from openness to commitment, from alternatives to record, from what could happen to what has happened. This is why memory and measurement cannot be separated. Without memory, an event would not fully enter the fabric of the world. It would flicker without inheritance, without consequence, without becoming part of the structure from which later facts emerge. But with memory, the result is no longer just local. It propagates. It affects new interactions. It constrains what can come next. It becomes part of the universe's account of itself. This makes fact something richer than simple occurrence. A fact is not just an outcome. It is an outcome that endures, an event that has acquired temporal weight, something stable enough to be carried forward by the world. And once we see that, the quantum problem changes again. The mystery is not only why one result appears, it is also how one result becomes history, how actuality enters time, how the present stops being merely possible and becomes irreversible. This is why the birth of a fact feels so profound, because every fact is a crossing from openness into memory, from quantum possibility into temporal reality, from the undecided into the recorded. And this may explain why our experience feels so different from the underlying theory. Quantum theory speaks the language of possibilities. Experience speaks the language of memory. Physics can describe what may occur. Life is built from what remains that we do not remember. Superpositions, we remember outcomes, we do not suffer. Probability distributions, we suffer events. We love particular faces, particular voices, particular losses. Conscious life unfolds inside the domain, where facts have already become time. That is why definiteness matters so much. Not because uncertainty is unreal, but because memory requires commitment. A world becomes livable when some things stop being merely possible and begin to endure as part of a shared past. And yet this leads to a darker thought. If a fact is born through record, through persistence, through entry into history, then history itself may not be a passive container. It may be the ongoing accumulation of resolved reality. The past, then, is not merely a shelf of dead events. It is the expanding structure of what has become definite, a growing archive of selections the world can no longer take back. That gives time a different meaning. Time is not just the stage on which facts appear. It may be the process through which reality becomes more and more committed, more and more recorded, more and more unable to return to pure openness. In that sense, the universe does not simply move through time. It writes itself into time, fact by fact, record by record. And once that is said, the original question returns in a new form. Does reality exist before measurement? Perhaps yes, but before measurement, reality may not yet belong to history. In the same way, it may be real without yet being recorded, structured without yet being fixed, present without yet being committed to one irreversible line. Measurement, then, is not only the emergence of outcome, it is the entrance of outcome into time, the moment. A possibility stops being one option among many and becomes part of the irreversible architecture of the real. And if that is true, then the deepest picture of reality may not be a world of finished things resting in silence. It may be a world that is continuously becoming, a world not only of being, but of irreversible arrival, a world in which facts are born, stabilized, remembered, and woven into the growing fabric of what is, which leads us to the final synthesis. Perhaps reality is not best understood as a completed inventory. Perhaps it is better understood as a process, a world that does not merely exist, but becomes. By now that the old image of reality has almost disappeared, the world no longer looks like a finished collection of objects sitting silently in space, each carrying its full identity, whether anything happens or not. Instead, a different picture has begun to emerge. Not a world of fixed things, a world of becoming, a world in which possibility, interaction, record, and fact are woven together. A world that is not unreal before measurement, but not always final, not empty, before observation, but not always settled into one classical form. This is the great shift. The question was never whether reality exists or does not exist. The deeper question is, in what mode does it exist before it becomes fact? Quantum theory has led us, again and again, to the same threshold. Before measurement, a spread of possibilities. After measurement, a definite outcome. Before record, openness. After record, history. Before stabilization, many available futures. After stabilization, one past. This is why the language of static being begins to fail, because being at the deepest level may not be enough. to describe the world. The world may be real, but reality may be dynamic, all the way down. Not a warehouse of completed facts, a process through which facts emerge. This idea does not belong to one interpretation alone. Copenhagen hints at it by tying meaning to measurable outcomes. Many worlds transforms it into branching actuality. Bohm preserves definiteness, but still requires a hidden unfolding order. Relational quantum mechanics locates fact inside interaction. Decoherence explains how stable classical appearance grows out of quantum entanglement, different routes, different metaphysics, but beneath them, the same pressure. Reality is not simple. Reality is not merely what already is. Reality is also what is becoming definite. That is why the word world must be treated carefully. We usually imagine a world as a finished stage, a place where everything already exists, fully formed, waiting to be noticed. But quantum thought suggests a subtler possibility. The world may be less like a stage and more like an unfolding verdict, less like a completed map and more like a continuous crystallization of events. Not because law is absent, not because chaos rules, but because law itself may govern. How possibility becomes actual, how openness narrows, how one line of history stabilizes from many allowed structures. This does not make reality fragile or subjective. It makes it alive in a deeper sense. Alive not as biology, alive as process, alive as emergence, alive as continual arrival into fact. And this changes what objectivity means. Objectivity may no longer mean a frozen reality, fully complete. Before every relation, it may mean the stable convergence of records, interactions, and endurable facts across a world, constantly becoming definite. Objectivity, then, is not the denial of becoming. It is what survives becoming, what remains stable. After interaction, what can be shared, remembered, and built upon. That is why the classical world still matters. It is not false. It is condensed reality, stabilized reality. Reality after enough interaction, enough entanglement, enough history, enough memory to harden possibility into a common world. A table is real, a planet is real, a body is real, but perhaps these are not the first forms of the real. They are the later forms, the enduring forms, the forms that have survived the long passage from quantum openness to classical permanence. So when we ask whether reality exists before measurement, the mature answer may no longer be a simple yes or no. Yes, reality exists, but perhaps not as a world of finished things. Yes, something is there, but perhaps there is already too classical a word. Before measurement, reality may exist as law, structure, relation, potential, amplitude, ordered possibility. After measurement, that same reality enters another mode: fact, record, outcome, history. Neither side is unreal, but they are not the same. One is the openness from which events can emerge. The other is the event that has emerged. One is the field of what may become. The other is what has become. And this may be the deepest lesson quantum theory offers. Reality is not split between illusion and truth. It is layered, potential and actual, possible and recorded, quantum and classical, open and settled. The mistake was always to demand that only one layer count as real. But perhaps reality is larger than that. Perhaps it includes both the unresolved and the resolved, both the possible and the factual, both the hidden grammar and the spoken sentence. And if so, then measurement is not the moment something appears out of nothing. It is the moment one path through reality becomes committed. The moment one branch of possibility acquires the weight of fact. The moment the world moves further from openness into form. That is why a fact matters, not because it cancels everything unreal, but because it marks a decision within the structure of the real, a narrowing, a stabilization, a becoming, and perhaps this is also why human life feels the way it does. We do not live at the level of pure possibility. We live inside stabilized worlds, inside irreversible events, inside the consequences of what has become. And yet, but beneath every certainty, the deeper openness remains. The world is stable, but not simple. Definite, but not primitively so. Real, but perhaps more fluid at its roots than our senses can show. So the final question returns one last time. Does reality exist before measurement? Yes, perhaps, but not yet. As the completed world we usually imagine. Before measurement, reality may be a structured becoming, not a finished inventory, but a lawful openness from which facts are born. And if that is true, then the universe is not merely a thing, it is an unfolding, not merely being, becoming. And that is where the final chapter begins. Not with another theory, but with the question itself now transformed. We have arrived at the question itself, not as it first appeared, simple, sharp, almost naive, but transformed by everything we have passed through. At the beginning, it sounded like a choice. Either reality exists before measurement or it does not. Either the world is already there, fully formed, complete in every detail, or something impossible. Must be true, but now, that old form of the question has broken open because quantum theory did not merely challenge one scientific assumption. It challenged a habit of thought, the habit of believing that only one kind of reality can count as real, the finished kind, the settled kind, the classical kind, the kind that appears as fact, record, outcome, history. And that is why the question was so difficult, not because reality must vanish without observers, not because consciousness secretly dreams the universe, not because nothing exists until a measurement occurs. Those were always the weakest answers. The deeper answer is harder and more beautiful. Reality may exist before measurement, but not yet. As a world of completed facts, before measurement, reality may be real. As structure, as law, as relation, as amplitude, as ordered possibility, as a field of constrained potential from which definite events can emerge. Not nothing, not illusion, not fiction, but not yet. The singular finished world that classical intuition expects. This is the heart of the transformation. Measurement does not necessarily create reality. From emptiness, it may do something more precise. It may bring one aspect of reality. Into definiteness, it may turn structured openness into event, possibility and into record, potential into fact, the unresolved into the remembered. And that means the final answer cannot be a simple yes or a simple number. Does reality exist before measurement? Yes. If by reality we mean a lawful order of possibilities, relations, and physical structure. No. If by reality we mean the fully classical world of single settled facts, already complete in every detail, the truth may lie between those meanings, or rather, beneath them. Reality before measurement may not be absent, it may be unfinished, not incomplete in the sense of defective, but incomplete in the sense of still open, still uncommitted, still containing more than one available future. And measurement on then would not be the invention of the world, it would be the narrowing of the world. The moment one line of possibility acquires the weight of actuality, the moment one event enters history, the moment the universe in one place stops hovering among alternatives and speaks. This view does not solve every mystery. It leaves us with deep questions. What exactly is the wave function? What finally accounts for one outcome? Are facts absolute or relational? Does branching occur? Do hidden variables exist? Is collapse real or only apparent? These questions remain, and perhaps they should remain, because the power of quantum theory is not only that it gives answers. It also teaches the limits of the questions we once thought were obvious. It teaches humility. It teaches that reality may be richer than objecthood, richer than location, richer than the language. Our senses built for survival. And in that humility, something extraordinary appears. The universe is not less real than we believed. It is more subtle, less like a warehouse of finished things, more like a living order in which fact emerges from possibility, less like a static sculpture, more like a continuous crystallization of event. And perhaps that is why this question reaches so far beyond physics, because it touches the structure of existence itself. We too live between possibility and fact. Every life begins as openness. Every choice narrows. Every memory records. Every moment passes from what may happen into what has happened. In that sense, the universe outside us and the life within us share a hidden rhythm, becoming, not instant completion, not fixed perfection, becoming, and that may be the final lesson. Reality does not wait as nothing until measurement calls it forth, but neither is it always a finished world, silently complete before every interaction. It may be something greater than both pictures, a real but open order, a lawful depth of possibilities, a world not yet false, not yet final. And when interaction occurs, when distinction stabilizes, when record is born, when one event survives, that open reality does not begin from nothing. It becomes specific. It becomes historical. It becomes this particle here, this mark, this memory, this fact. So does reality exist before measurement? Perhaps the most honest answer is this: yes. But before measurement, reality may exist. Not as a world of finished things, but as a world of possible ones. A world waiting, not to be imagined, not to be wished into being, but to become. And maybe that is the deepest truth quantum theory leaves us with, that reality is not only what is, it is also what can become. And the universe, before every fact, stands for one suspended moment at the edge of both.